Hi everyone. Now we are going to discuss about the voltage regulator by using Zener diode. Here we are finding Zener current and the power dissipation across the Zener diode. Initially we will consider ideal Zener diode. Let us draw the circuit. Initially I am considering the Zener diode. And the resistor R1 and another one resistor parallel to the Zener diode, the load resistor, and supply voltages Vs. Let us connect together. Positive polarity of the volt supply is connected to the R1 and R1 to the load and the Zener diode. And let us connect the ground. Okay, and we will define the values. Here I am considering the 500 ohm for the R1 and I am considering 1 kilo ohm for the resistor RL, and we are applying the 10 volt supply. Let us define the Zener diode model. Here I am considering the model D dot when it is R on equal to 0 ohm, when it is R off equal to 1 mega ohm, voltage forward is equal to 0, ideal Zener diode, and voltage reverse I am defining the 5 volt, and the maximum Zener current IBV. Okay, I am considering it is 50 milliamps. After this I need to connect the ground. Here we are defined VZ, Zener voltage as 5 volt. Initially we need to confirm voltage across the Zener diode should be more than the 5 volt. Okay, because in the Zener diode, if the source voltage is more than the VZ only, the Zener diode will operate in breakdown region. So we will confirm it. Let us put this as a node A and this as a node B. Okay, let us move this Zener diode node A, and for that we need to find the Thevenin's voltage across the node A and node B. As we know, Thevenin's voltage VTH is equal to Vs into RL, means here R2, okay, divided by R1 plus R2. Okay, so that here Vs is equal to 10 volt into 1 kilo ohm divided by 1 kilo ohm plus 500 ohm. Okay. When we simplify this, we are getting 6.667 volt. So the Thevenin's voltage across node A and node B is more than the 5 volt. So we can conclude that this Zener diode working in the breakdown region, so that it will provide the constant voltage across the load. Okay, here we can define it as RL and it is RS, series resistance RS. As per this Thevenin's voltage, we can conclude we are getting the constant voltage on the load. So here we are getting the constant 5 volt. Okay, now we can find out the current across the load. So current across the load IL is equal to Vz divided by RL. Which is equal to 5 volt divided by 1 kilo ohm. Okay, and which is equal to 5 milliamps. So that current through the load is 5 milliamps. So we need to find current through. So we need to find current across the Zener diode. For this, we need to apply the KCL rule at the node A. So that IS is equal to, here IS means source current IS, and this is the IZ, and this is the IL. So that as per KCL rule, IS is equal to IZ plus IL. Okay, and so we need to find the current across the source resistor, which is equal to IS is equal to Vs minus Vz divided by Rs. Okay, which is equal to 10 volt minus 5 volt divided by 500 ohm. Okay, and when we simplify this, we are getting, and when we are simplifying this, we are getting 10 milliamps. So the 10 milliamps current flow across the resistor R1. So now we can find the current through the Zener diode. By rearranging this, IZ is equal to IS minus IL, which is equal to 10 milliamps minus 5 milliamps, which is equal to 5 milliamps. So current across this Zener diode is IZ is equal to 5 milliamps. So now easy to find the power dissipation across the Zener diode. The formula for the power dissipation across the Zener diode is Vz is equal to Vz into Iz, which is equal to 5 volt Vz into Iz is equal to 5 milliamps. So it is equal to 25 milliwatt. Let us conclude this with the simulation. Initially, I will remove this diode and I will run this. Okay. What is the voltage we are getting here? 6.66. Our theoretical calculation is matching. Yeah. Similarly, current across this Zener diode is 5 milliamps. Okay, and similarly current across this load resistance is 5 milliamps. Okay, current across this series resistance is 10 milliamps. So our calculation is matching with our simulated value. Hope you are able to understand this circuit. Thank you for the watching.